Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In the previous lecture, we have discussed about what is recursion and what is a recursive function, why do we need recursion, right? In today's lecture, we'll be solving some problem. So let's go with basic for the first problem. So let's say you are given an array, okay, nums of integers, okay. Now you have to traverse the array, but recursively. How we can do? Let's see. So to do it recursively, what we have to take first, we have to create a function, right? We have to create a function. And what we'll do, so let's see, let's write a function def and name it as traverse array or list. Okay, then let's say it will take the array nums and it will take index of the array. Okay, now we have discussed in recursion there are three steps, right? First is base case, like the condition where to stop the execution, right? Where to stop the execution of the function. Then second thing is we'll do some operation, and the third thing is we'll call the function again. Now let's see how we can do this. First, write the base case of it. Okay, what we'll do, what is our plan? First we'll call this function. We'll call this function, and we expect that we pass this integer, so index as 0. That means for the first function, we are expecting that it will print index number 0, means the first element. Then it will call this function again to print the remaining elements. So we only expect the function first, it will print the first element at index 0. Then it will call the function again to print remaining element. Okay, that is our funda. That means at last, when we invoke, what we'll do, we'll call this function as traverse list, then we pass this nums, okay, and pass this index as 0. This will be our first step. Okay, then okay, let's see how we can write this. First, base condition, where to stop execution. Let's say I can print index 0, index 1, index 2, right? But the length here of the array is 6, right? So if the index is 6 or 7 or 8, then we get the result? No, right? That means array index out of band. We'll get that error. So base condition will be if this I is greater than equals to length of this nums, then what we'll do? We have to return. Then we will not print the elements again. So this is our base case. Then what is the next thing? Next thing will be doing some operation. Here, what is the operation? We have to print the number, right? So we'll take the operation. So print, so element, so how we can print the element nums of this I, whatever I we have passed, right? So this is our operation is taken. Now what we'll do, we have taken our step, right? We have done this operation. Then we expect this traverse list and pass this nums and I plus 1. That means we expect we'll call this function again, and we'll expect this function will get our result, right? This is the code, and at last we'll be returning. So you can write, or automatically it will return, right? Now let's see if we run this. Now you can see first 10 is printed, then 20 is printed, then 30, then 40, then 60, then 70, right? So first we are just invoking this function with index 0. Then in the first time, first it will check the base case. So is I is exceeding the length of this array? No, right? Then what we'll do, we'll print this number, then it will call this function again, but this time index will be incremented by 1, right? Index will be incremented by 1. Then what it will print? It will print the second element, right? Then then third element, then fourth element, then fifth element, then sixth element. But when I is equals to length of the array, that means I is equals to 6, then it will stop it execution, right? Now let's say before doing this operation, let's call the function first. Let's call the function first and do the operation at last. Okay, then what will happen? Now if you run this code, now you can see this is printing in reverse order. That means first it will call the function and it will wait to execute. So first it will, what it will expect, it will expect that first print the all elements, the remaining element, then at last it will print the element at index 0, right, at index 0. Similarly for index 1, first it will expect that first it will print those element, then at last it will print this, right? So this is a simple problem using recursion how we can traverse an array. Now let's look at our next problem. Let's say you are given a number n equals to 5. You have to calculate the factorial of this number, factorial of 5. Now how we can calculate the factorial of a number? Let's say you are providing a number, okay, n, okay, let's say n equals to 5. Now what will be factorial of 5? Factorial of 5 will be nothing but 5 into 4 into 3 into 2 into 1, right? Means we'll be multiplying all the numbers that are less than 5, right? Okay, now how we can solve this using recursion? Now in recursion there are three steps, right? First is base case, then we'll do some operation, then we'll call the function again, right? So let's say when we call, let's say we create a function fact of n, okay, let's say i only so I only concerned about our current number, right? If I have to evaluate factorial of n, factorial of 5, then I'll be only doing factorial of 5, and whatever the remaining things that I expect will do factorial of 4. Factorial of 4 will be doing this, and then what will be the output here? Whatever factorial 4 give me the output, I'll multiply this with 5. I'll multiply this with 5. Now let's say, so what I mean by that, let's say what will be the factorial of 4? So let's say 4 factorial. What will be the output? 4 into 3 into 2 into 1, right? What is factorial 3? 3 into 2 into 1, right? 3 into 2 into 1. Let's say I want factorial of 5. Factorial of 5. Then what I'll do first, I'll call factorial of 4. Okay, so let's remove this, let's simplify this. So what I'll expect, factorial of 4 will give us some number, right? Then whatever number I'll get, I'll multiply by 5. Similarly for factorial 4, what I expect, so whatever factorial 3 give us the output, I'll multiply this with 4. Similarly for factorial 3, what I expect, factorial 2 multiply by 3, right? Factorial 2 3 means factor number 3 multiplied by factorial 2. So this means I am calling this factorial function again. I'm calling this function again, and what operation I'm doing, whatever result I'm getting, I am multiplying by the current number. That only I'm doing. First I'm expecting this will give me the result, then whatever result I get, whatever number I'll return, I'll multiply them by current number. Okay, so you got whatever step we have to taken. So the in step whatever we have to taken, we have to return n, current n, and we will expect this factorial of n minus 1 will give me the result, right? So that is means I am calling the function again, and this is the operation I am doing when I get the result. Now what is the base case? Let's say I want to calculate factorial 5. Then I'll multiply 5 with 4, 3, 2, 1, right? Then when I'm at 1, can I go further? Let's say I calculate factorial of 1. Okay. Then should I call factorial of 0? Or if I calculate factorial of 0, should I call factorial of minus 1? No, right? That means if I get the number as 1, there I have to stop. So what will be our base case? Base case will be if n is less than or equals to 1, then what we'll do? We'll return 1. Right? This is our base case. Now let's see by how we can write the program for this. First, write the base case. So base case will be if n less than equals to 1. Okay, or we can write equals to 1 also. That will also give us the result. Then return 1. Okay, this is the base case. Then what we'll do, we'll be returning this n into, and we'll expect that factorial of n minus 1 will give us the answer, right? So then at last we'll be storing this inside this result variable. Okay, then we'll just print this out. Print factorial of, let's say, n is a result. Okay, now let's run this. So you can see we get the result. Factorial of 5 is 120, right? I hope now you have understood how using recursion we can solve this problem. Now let's look at our next problem. Let's say you will be given a number n equals to, let's say, 10, and you have to tell nth Fibonacci number. What will be nth Fibonacci number? So what is Fibonacci series? So as you know, Fibonacci series always start with two elements, 0 and then 1, and then each element is basically sum of previous two element. That, so this is first element, this is second element. So third element, what will be the third element? That will be basically sum of first and second, right? So 0 plus 1 means 1. Okay, 0 plus 1 means 1. Then what will be the fourth number? Fourth number will be sum of previous two number, right? Second and third. So 1 plus 1, 2. Then what will be fifth number? Fifth number will be sum of previous two number, 3. Then what will be the next number? 2 plus 3 will be 5. Then what will be the next number? 3 plus 5 equals to 8. Then 5 plus 8 equals to 13, right? Then 8 plus 13 equals to 21, right? Like so, go on. Now let's see how we can write a program to basically find what will be the nth Fibonacci number. Let's say nth Fibonacci number. Let's say nth Fibonacci number is f of n. Okay, that what it will be? It will be of, so n minus 1th number, Fibonacci of n minus 1th number, then n minus 2th number, right? The sum of these two number will be current number. Now let's say at n equals to 5. Let's say at n equals to 5. At n equals to 5, that means f of 5, if we know what is f of 4, and if we know what is f of 3, that means, so n is 5, that means 5 minus 1, 5 minus 2. If we know these two number, then we can find this number, right? Now to solve f of 4, what we have to know? To solve f of 4, we have to know f of 3 and f of 2, right? F of 3 and f of 2. Similarly, to calculate f of 3, what we have to know? F of 2 and f of 1, right? F of 2 and f of 1. Now here similarly, to calculate f of 3, we have to know f of 2, f of 1. So here we have to know f of 1 and f of 0. And to calculate f of 2, we have to calculate f of 1, f of 0. We'll not go further after 0. We'll not go to minus 1, right? We'll not go to negative because number is not possible. So for here also, to solve f of 2, what we can do? We can take f of 1 and f of 0, right? Now here you can see, if we know f of 1 and f of 0, if we know f of 1 and f of 0, right? F of 1 and f of 0, then we can solve this problem easily. What we have to know? We have to know two things. We have to know first element and second element, right? We have to know only first element and second element, f of 0 and f of 1. So if f of 0 equals to, means 0th element, so f of 0 is 0 and f of 1 is 1. F of 0 is 0 and f of 1 is 1. Then what we can do? We can solve this problem by in any certain point f of n equals to f of n minus 1 and f of n minus 2. So using recursion, we can do this. But observe carefully here. Here to solve this particular problem, we are calling this function twice, right? We are calling this function twice. That's why it will create a tree-like structure. A tree-like structure that is called a recursive tree. That is called recursive tree, right? Now let's see how we can solve this problem. So let's say n equals to, we have to find 10th number in the Fibonacci series. So first let's create a function def fib of it will take a number, right, n. And what is the initial condition? Initial condition, if the first element, what is the first element? Zeroth element, right? Okay, if n equals to 0, then we have to return 0. And if n equals to 1, then what we can do? We can return 1. So this is our base condition. This is our base condition. But we can merge these two things and write like, if n equals to 0 and or n equals to 1, then just return n. That means if n equals to 0, then it will return 0. If n equals to 1, then it will return 1, right? So in single line we can write. And then what I can do, so our current number, current Fibonacci number, so current number equals to fib of n minus 1, right, and plus fib of n minus 2. We have to evaluate the first the previous two element, right? Then we can find the current element. So then just simple, we have to return current number. Okay, so that's it. This is the solution. This is the base case. Say here we are calling the function again, and we are doing the operation summing up, by summing up, and we are returning the function, right? Returning the output. Let's print this. So print, let's take a result. So result num equals to resultant num equals to, will be calling this Fibonacci number and pass in here. And now let's print in fee number is, and it will be basically resultant number, right? Now let's run this. So here you can see 10th Fibonacci number is 55. That is true. So if we calculate, let's say, second Fibonacci number, what it will be? First 0, then 1, then 0 plus 1 will be 1, right? So let's say, so here, yeah, second Fibonacci number is 1, right? So I hope now you have understood how we can, using recursion, we can solve this. What will the Nth Fibonacci number?